The woolly mammoth, one of the best-known megafauna of the Ice Age, roamed the northern hemisphere for hundreds of thousands of years. Known for their long, spiraling tusks, dense fur, and imposing stature, they were perfectly adapted to the harsh glacial environments. Often depicted in cave art by early humans, the woolly mammoth has become a symbol of prehistoric life. Mammoths were widespread, living across North America, Europe, and Asia. Their preferred habitat, known as the Mammoth Steppe, was a vast, cold grassland filled with hardy grasses and herbaceous plants, stretching from Spain to Siberia and into Alaska. The woolly mammoth stood about 9 to 11 feet tall and weighed up to 6 to 8 tons, similar in size to today's African elephants but more robust. Their thick fur, up to 3 feet long in some places, consisted of an outer layer of long guard hairs and an insulating undercoat, perfectly adapted for cold environments. They had a hump of fat on their back, helping them store energy and survive in the harsh Ice Age climate. Their tusks, which could grow up to 15 feet long, were not only used for defense and digging, but also displayed genetic health and strength during mating. Their large curved tusks served various purposes. Besides being a tool for breaking through snow and ice to find vegetation, these tusks played an important role in social behavior, including fighting for dominance during mating season. Their small ears, unlike their modern elephant cousins, were an adaptation to cold weather, reducing heat loss. Their hemoglobin was also uniquely adapted to allow oxygen to circulate efficiently, even in extreme cold. Much like today's elephants, woolly mammoths lived in tightly knit social groups. These herds were typically led by a matriarch, the oldest and most experienced female, who guided the group to food and safety. Mammoths likely communicated using low-frequency sounds and vibrations that traveled long distances, allowing them to stay in contact with other members of their herd. Woolly mammoths lived up to 60 years, and as they aged, they cycled through 6 sets of molars. The wearing down of these molars, combined with decreased foraging efficiency, was often a key cause of death among older mammoths. Mammoths were strict herbivores, primarily feeding on grasses, sedges, and shrubs. Due to their massive size, they required vast amounts of food, up to 300 to 400 pounds per day. During winter months, when food was scarce, they used their tusks to dig through snow and ice for hidden plants. Woolly mammoths undertook seasonal migrations in search of food. During warmer periods, they roamed farther north into Arctic regions, while in winter, they moved south into milder climates. Fossil evidence, including bone and tusk isotopes, shows that mammoths moved hundreds of miles throughout the year to find food, water, and safety. The glacial cycles, which alternated between cold, glacial, and warm, interglacial periods, had a profound effect on woolly mammoth migrations. During colder periods, the expanding ice sheets limited their habitat to the southern fringes of their range, whereas during warmer times, they expanded northward into newly available grasslands. One of the most significant migration events occurred when mammoths crossed the Bering Land Bridge, a vast expanse of land that connected Siberia to Alaska during lower sea levels. This allowed mammoths to spread into North America, diversifying their population and ensuring their survival for millennia. As the planet warmed at the end of the last ice age, around 12,000 years ago, the mammoth steppe transformed. Grassy plains gave way to denser forests and boggy wetlands, which could not support large grazing animals like woolly mammoths. The warmer climate led to the melting of permafrost and the shrinking of tundra ecosystems, forcing mammoth populations into smaller, fragmented pockets. This change in habitat severely limited their access to food. Early human populations, such as the Clovis people in North America, hunted woolly mammoths for their meat, bones, and fur. Mammoth bones discovered at archaeological sites show clear signs of butchering, and evidence from spear points suggests organized hunts. Some scientists argue that human hunting, while significant, may not have been the sole cause of the woolly mammoth's extinction. Instead, it may have been a combination of hunting and environmental pressures that finally led to their demise. As mammoth populations dwindled, they became more isolated, leading to inbreeding and a loss of genetic diversity. Recent studies of DNA from late surviving mammoths show that these isolated populations suffered from genetic defects, further reducing their survival chances. Interestingly, a small population of woolly mammoths survived on Wrangel Island in the Arctic Ocean until about 4,000 years ago, long after most mammoths had gone extinct on the mainland. These dwarfed mammoths lived in isolation but eventually succumbed to environmental pressures and genetic collapse. In recent years, scientists have turned to the possibility of reviving the woolly mammoth using cloning and genetic engineering. With advancements in DNA extraction and sequencing, researchers have managed to retrieve and analyze the woolly mammoth genome from well-preserved carcasses found in Siberian permafrost. One method involves taking a viable woolly mammoth cell and cloning it using an Asian elephant, the closest living relative of the mammoth. The idea is to implant the mammoth DNA into an elephant egg and have an elephant carry the cloned mammoth calf to term. A more feasible approach is to use CRISPR gene editing technology to splice woolly mammoth genes into the genome of an Asian elephant. By introducing genes responsible for traits like fur, fat deposits, and cold-adapted hemoglobin, scientists hope to create a mammophant, an elephant-mammoth hybrid capable of surviving in cold climates. The ultimate goal is to release these mammoth-like creatures into Arctic environments to promote the growth of grasslands and slow the thawing of permafrost, potentially mitigating the effects of climate change. De-extinction raises profound ethical questions. Should we bring back a species that went extinct thousands of years ago? Can we guarantee that a resurrected mammoth will have a place in today's ecosystems? And what are the consequences for the surrogate elephants used in this process? Some scientists argue that reintroducing woolly mammoths could help restore balance to tundra ecosystems. By trampling forests and promoting grass growth, mammoths might help lock carbon into the soil, preventing it from being released into the atmosphere as the permafrost thaws. Woolly mammoths dominated the Ice Age landscape for hundreds of thousands of years, adapting to some of the harshest environments in Earth's history. Their extinction marked the end of a prehistoric era, but their legacy lives on through the fossils, DNA, and cave art left behind. As science advances, the potential revival of the woolly mammoth could not only bring this ancient giant back to life, but also open a new chapter in the relationship between humanity, nature, and technology.